The next characteristic of data we're going to talk about is dispersion, or differences amongst different data types. It's nice to know what the average value is, whether it be the median or mean, but how far off from the average is it? So there's a couple of different ways that we can describe that. So we're going to start with sort of this little thought experiment of here's a collection of data of 30 random customers during lunch hour at two different restaurants. Which one would you rather wait in and why? So let's take out our calculator, and then we're going to type in this information and create a histogram over that. And at this point, we've done enough histograms and calculator skills that I'm just going to jump straight to the picture. Okay, so hopefully you got something similar to this. And as you're looking at it, I want to think about which place would you rather go to just based on wait time. Both of them have people that wait a long time, and yet there is a distinct difference between how the two graphs look. Okay. Notice that McDonald's is fairly uniform. If they don't get you in the first 30 seconds, there's an equal likelihood that you're going to wait anywhere from a minute to 5 minutes, and they're all pretty consistent at that point. Whereas at Wendy's, they might not get to you for a minute or a minute and a half, but that's pretty much about as much as you're going to wait. Um, so back to the question is, how do we measure something like this? What's the differences? Well, one difference would be range. And range is what we think it is. It's the largest value minus the smallest value. It just gives us an indicator of the size of the entire data set. Okay, so if I want to find range, then just simply figure out what the biggest number is, which in this case is 43, and then the smallest is 5. And once I subtract that, I get 38. Okay, so the range is 38. Another measure we're going to talk about, and this is going to take us a few minutes, is called standard deviation. We've got population and we've got sample that we'll get to eventually here. But population standard deviation is represented by the Greek letter sigma. Looks like a fancy looking O with a little tail out the side. We use standard deviation to describe how far off the typical value is from the mean. Okay, and it's got this nice lovely set of formulas which I'm going to walk you through how to calculate what it's trying to get you to do, because on the surface it looks pretty scary here, but like I said, I'll walk you through it. Okay, so we're gonna calculate these numbers filling out this chart here. So the xi simply represents the observation. So I'm gonna type in the numbers, and then I'm gonna go to the calculator, and I'm gonna input these same numbers into the calculator. Okay, and then I'm going to use the calculator to find the mean. Actually, I'm going to cheat and just go up top here because I already did this earlier. And I get a mean of 24.86-ish. Okay, so I'm going to go into my chart here, and I'm just going to type in that number. Actually, I'm going to cheat, but trying to set this up for you so you can see what happens each step of the way. Okay, so now what I want to do is I want to subtract these two things. So I can do that by hand, but the calculator's nice in that it will help us do some of these calculations for us. So if I go back to, actually let me stay on the home screen for a second. Let me get that number back again, because I was doing something else, so I got rid of it. Let me get the mean of list 1. Okay, so I got that number. Now I'm going to take that number, and I believe you can just hit store, and it will take the answer from the previous step, and we're going to associate it with a letter. So I'm going to tell the calculator, I want you to remember A as this mean. And until we reset it, it's going to keep that number stored in its memory. Okay, so I'm going to hit enter. And now every time I hit the letter A, it's going to pop up that number. Okay, so let me go to stat list. Let me go to edit, and this time I'm going to go to list 2. And I'm going to go on top of list 2. Okay, you can do this. Be very, very careful not to hit delete though. So on top of list 2, I'm going to edit it. I'm going to define a formula for list 2. And in list 2, I want it to go the observation minus the mean. So that would be list 1 minus A is what I'm going to type in. So I'm going to go hit second list to pull up list 1, and then minus that A. So hit alpha A, letter A. So it should look like this, L1 minus A. Then I'm going to hit enter, and it's going to give me a big giant list of all of these numbers that I am going to summarize in that table, theoretically summarize in the table. Okay, so negative 1.86, 11.143, negative 1.86, negative 6.86. Wow, that's an interesting 86 pattern here. Negative 19.86, 1.14, I guess 14 is fine, and then 18.143 is fine. Okay, now you would think if we're just trying to measure averages that we would want to add these up because these should tell us how, I mean, this is a measure of how far off every number is. And if I want an average measure of how far off every number is, I would stop here, right? We're going to do something with this because if we're averaging things, that means add them up and divide. So we've got 7 numbers. So if I add them up and divide, something interesting happens. So let me go to the home screen again. And I believe if we go to math, we should see the word sum. And I'm going to sum list 2. Now list 2 is that bunch of numbers I just wrote down. And I'm going to have the calculator add them up and tell me what they add up to. And then in theory, I would take that and divide by 7. Now, we already get this interesting number. We get this. I have mine at negative 1.42 e to the negative 13. Well, e to the negative 13 means 0.000000000. It's 0 is what happened. If I sum this up, I get 0. And that's what should happen because that's what the mean represents. It's the average value. So if I take all the numbers and I find that middle balancing point, that's what the mean does. So to counteract that, because I want to have a number that measures how far off each observation typically is, that's why we square it. So I'm going to go back to my stat list, edit. And now we're going to go to list 3, and on top of list 3, I'm going to square all of these numbers from list 2. So I want highlight the top and then hit second list, have L2 show up, and I just want to square that. So you can either hit the squared button or the caret 2 button, either one will work. And it takes all the numbers and it squares them. Now at this point we have something different than standard deviation. We have something called variance, but again we'll get to that. And so at this, let me kind of go back to the formula here. Oh, where'd the formula? Oh, sorry. Let me go to the formula here. What the formula says, it says to add up, that symbol there means sum, it says add up all the differences squared, divide it by the total, and then take the square root. Okay, so if I go to the home screen, L3 is all of those squared things. So I'm going to sum up the squareds. So sum up L3. That gives me a number. And then I want to divide that by the total number of observations, so divide that by 7. And then I want to take the square root of that, which is right there. So second x squared. And then some calculators let you highlight it and copy and paste it in, or you can just type in the number. And then I'll hit enter. So the standard deviation then for our set of data is 11.36. Okay, so anyways, we calculated population standard deviation off that. Now we're going to look at this computational formula, this other form of the population standard deviation, which says if I square the observation and add it, and then add all the observations and square it, I get, it's another way to get the formula, to get the same standard deviation. So it's kind of an interesting math process that shows up here. So let me go back and see if we have all of our things we need. Okay, now why not? Okay, so I need to square my numbers, square the observations, so I need to square list 1. I haven't done that yet. Let me get rid of all these other numbers here. So let me get rid of that. So I'll get rid of L3, get rid of L2. Okay, so in L2, I want to square L1. So I'm going to go up top, highlight L2, and then just tell the calculator square L1. So find L1, square it. Okay. And that's pretty much all I need, is that right there, and that should be enough to calculate standard deviation, is that one list in L2. So I need L1 and L2 to say what they currently say, but then I can manipulate the formula from here. Okay, so according to this formula, let me go back to the home screen. I want to sum the squareds. So that would be list 2. So let me go second list, math, and we want to sum list 2. Okay, I get a number. Then I want to sum list 1, but then I want to square that. So that's what this is saying right here. It says sum list 1. So let me go back and get the sum again, but this time I want to sum list 1. Okay, so this says take that number, that 174, and square it. Okay, I get a number. And then divide that by the observations, which is 7. So I get that number. And now I want to take that first squared minus the new number I just found. So that 5280 minus the other number I just got. And then I want to take that thing and divide that by 7. And then I want to take the square root. And the really cool thing is, it should match. It's kind of creepy that it works out that way. So anyways, this one, either formula is fine. It's just this computational formula requires less table work on our part. There's less things we have to do to calculate it, and we still get the standard deviation to show up. So 11.36 for it.